So hello, my name is Lucie, and I would like to present our work, investigation of point merge utilization worldwide using Opensky network data, which I worked on together with my supervisor Tatiana Polishuk and another PhD student, Henrik Hardel. We are from Sweden. So a little bit of introduction. So point merge is developed by Eurocontrol. It was developed in 2006 and is already actively used at 38 airports around the world. And it improves capacity and workload for the air traffic controllers. So it is there is many variations of point merge. You can see a few of the main published by Eurocontrol in a picture. The idea is that the flight follows the sequencing legs, and then when the correct spacing and metering is reached, they are told to go to the merge point on the top of the triangle. And these are the three main variations with fully overlapping sequencing legs, partially overlapping, and fully dissociated. The full overlapping are giving better capacity, but the fully dissociated are better for the environment and for performance. So in this work, we investigate the usage of this point merge procedure around several airports worldwide. And we analyze the arrival flows, and we propose catchment algorithm, and we apply our two metrics which were developed specifically for this work. So the airports we are working with is London City Airport, which operates one overlapping system. The interesting thing about this point merge is that there is one point merge system shared with two airports, London City and London Biggin Hill Airport. Then we analyzed Dublin Airport, which has one overlapping and one fully dissociated variation of point merge system. Bergen with two fully dissociated systems. Oslo with 4 overlapping systems. South Korean Seoul Incheon Airport with one overlapping point merge system and 1/2 of point merge system. Interesting thing about this airport is that the point merge systems are used in combination with trombones. So the aircraft fly to the point merge system, and then they proceed to the trombone system. Then we also had a look into Colombian airport, Bogota, which has one overlapping point merge system, and Russian St. Petersburg Pulkovo Airport, which operates 2 overlapping point merge systems. The locations can be seen on a world map. So data, we use Opensky network data, which might be incomplete or erroneous sometimes. So we apply some cleaning procedures. We remove fluctuations in latitude and longitude. We use a Gaussian filter to smooth altitudes. And then we remove incomplete or damaged trajectories and outliers, such as go-arounds, flights which did not land on the runway or landed too far from the runway, flights with departure and arrival at the same airport, and commercial and military aircraft trajectories. And for some airports, it was needed to determine the runway on which each aircraft landed. So the two metrics we use are point merge usage, which is the proportion or the percent of flights which are adhering to the point merge procedures, and point merge utilization, which is the proportion of the sequencing leg used by the aircraft of the point merge. So to identify the point merge utilization, we use circle catchment areas around waypoints, which can be seen on this picture. This is example of Oslo, one of PM systems of Oslo Gardermoen Airport, and you can see the green and the red circles. These are the waypoints on the sequencing legs, and we try to identify until which of them the flight reached during its landing. Then we have catchment algorithm, which we use to identify the flights which adhere to point merge procedures. We have the same picture here because for the airports, we also use the circular catchment areas, but we only put them on the starts of the sequencing legs where the aircraft flow is incoming to point merge, and this catchment algorithm is fine-tuned for each airport separately because the point merge configurations are quite unique usually. And yeah, we can see some examples here. We can see both sides of Dublin Airport, Dublin point merge systems, one of fully overlapping on left, in the middle fully dissociated. The red circles are the catchment areas. So in the left side, we can see that there is only 2 of them because there is only 2 places where aircraft fly into the point merge, but we have 4 in the fully dissociated areas because there is also another places where aircraft join the point merge. The same is on the right for Bogota Airport. To check the correctness of our algorithm, we plot the point merge flights and also all the flights which weren't not identified as point merge. At some airports, we had to have correct flights catched. We had to also use circular catchment areas around the preceding waypoints according to the published routes to the point merge, because some aircraft use different published routes which might be below or under, over or under the point merge system, so we want to filter them out. So this is an example of London City Airport point merge flights on the left and non-point merge on the right. So there are some results of point merge usage. So in average, there is 34% usage over these 7 airports. And the maximum of point merge usage was observed at Bogota El Dorado Airport, which was almost 70%, and around half of the flights use point merge at Dublin. And the airport which used the point merge least is Seoul Incheon Airport and Bergen airports. We can see from the number of all flights that the airports which use the point merge least are usually the less busy airports. Then we have results of point merge utilization. So during our calculations, we found a bit of a difficulty because some of the airports have, or all of the airports have different number of waypoints on the sequencing legs, and some of the airports actually have different number of waypoints on each of the sequencing legs of one point merge system, such as Dublin and Bogota. So it's a bit difficult to analyze when it's a different number of waypoints. Then we have some interesting results. The first table is for St. Petersburg Airport. The first 4 lines are for each point merge leg, sequencing leg, and the last line is for all the point merge at the airport. And for me, I think interesting is that each part of the point merge is used in a different way. For example, northwestern part, the flights usually just touch the start of the sequencing leg and then go directly to the point merge. But on the other side, on the other hand, on the southeastern part, most of the flights go at least the first segment of the point merge. Then the second example is Bogota Airport, and there is 2 lines because each of the sequencing legs have different granulation, but even though it's different granulation, we can see the same decrease of number of aircraft using the parts of the point merge. So as I said, there is a different granulation. Sometimes it's difficult to capture the differences, and Dublin and Bogota airports have uneven lengths. So we found out that most of the airports doesn't use the full capacity of their point merge system, and the full length of the point merge sequencing legs is used rarely. And the highest number of aircrafts which flew the whole length of the sequencing leg was at the Russian airport, St. Petersburg, and Oslo Gardermoen Airport and Seoul Incheon had the highest number of flights which go directly to the merge point. There are some more examples. This is St. Petersburg Airport on the left, Oslo, one part of point merge system of Oslo in the middle, and on the right there is Seoul Incheon Airport. We had to add additional criteria for Seoul Incheon Airport because many flights were going to the start of the point merge sequencing leg on the south, but then went directly to the runway and didn't go to the point merge. So we had to go at additional criteria that if the flights enter the sequencing legs, they also need to fly through the merge point. We also draw some PM utilization for all the airports. We can see that the curves have similar shape except Bergen Airport. And there is a steep decline of the curves until about 30% of point merge arcs. And then it's similarly low utilization, and most of the aircraft leave the point merge system or point merge sequencing legs at about 50% of the length. We also performed initial sensitivity analysis because we saw that in some airports, the circle catchment areas catch many flights which just go to the first point of the sequencing leg and then go directly to merge point, which is still in a discussion if those flights are considered point merge flights or not. We applied the initial sensitivity analysis to Oslo Gardermoen Airport when we tried to decrease the size of the radius of the catchment area, and we managed to filter out a little bit more false positive flights. So we will continue in this work, and we will try to come up with adaptive radius size for each airport according to the size of the airport. This is some results of the initial sensitivity analysis. You can see on the left there is a bigger radius size and smaller on the right. So we can see that it is very sensitive. Point merge usage metric is quite sensitive to these changes, but we didn't observe any significant difference in the point merge utilization results. Some conclusions. So we concluded that smaller or less busy airports use point merge system less often than the busier ones. Point merge system is not used to their full extent, and we would like to come up with adaptive radius size of the catchment areas for each airport. And also we found out that there is many false negative flights which are difficult to capture because sometimes the flights doesn't follow the published routes and they enter the point merge system somewhere else than they are supposed to be. So we would like to have a look inside the vertical aspect of trajectories to try to identify them as well. And we would like to do performance assessment of different point merge systems and implementations. And thank you.
Thank you so much, Lucie, for this interesting talk. Do we have questions? Yes.
Hello. Yes, many thanks for this very interesting presentation. I have a question regarding vectoring. Sometimes ATC will vector the aircraft around more or less the published procedure, but will not require the aircraft to follow the procedure exactly as if they were really flying from one waypoint to another one. Do you think this vectoring could happen often at those airports? And have you talked on how you could catch them? Because of course, if there is a vectoring by ATC, the radius of 3 nautical miles around the waypoint may not be fully respected because the ATC will fly them around an approximate vector, more or less following the track.
Yeah, so I think the having a look into the vertical aspect of the trajectories might help with this, because the point merge system or the point merge sequencing legs usually or always have some flight level which they need to maintain. So I hope this will help.
Thank you.
I have a difficult question for you. Sorry for that. So you mentioned a lot of statistics about how point merge are used. So easy question for me, not easy for you, is like, are the point merge more efficient than other ways to manage air traffic for landing aircraft?
So I think it's more efficient in busy or peak periods, because it helps to lessen the workload of the air traffic controllers, and there is designed routes that they know the flights needs to go there. But during off-peak hours, there is a bit. We found out in our previous studies that the flights usually spend a bit more fuel flying around those arcs. So
if there's not much traffic, of course the direct is more efficient, but like comparing point merge with other ways to regulate traffic, like to not regulate, but like to control traffic, like in terms of time, in terms of workload, in terms of maybe also environmental questions, like what do you think?
And so also when the aircraft leaves the sequencing leg, they can do full CDOs. So it's better for fuel consumption than if they might got delayed in a closer to the runway by vectoring or something.
So do you think all airports should use a point merge system?
I think it's difficult. It's not an easy question.
I didn't claim it to be an easy one. Any other question?
I have a question. You had some statistic about utilization of the point merge, so being it 40%, half of it of the full arc. Why did you calculate it? Because in the end, even if used, let's say, 50% of the arc, de facto point merge is only a way to better sequence flights to the runway. So the fact that you use 10% or 50% is so what was the thinking behind it?
Yeah, so we are thinking it's a quite a new concept, and it's nice to have it investigated, and also it can give information to the airport that they still have free capacity on this point merge system which they can use.
Any more questions in the audience? If not, I guess we can move on